Well, it should make sense that the probabilities of those two possibilities should add up to 1, because they should cover everything. Right? They're the only two possibilities. So the probabilities have to add up to 1. Same for here. If I already know it's rainy, again, the only two possibilities are that it's sunny the next day or it's rainy the next day. So since those are the only two possibilities, those probabilities have to add up to 1. Okay. Okay, so that's transition matrix. So what I want to do now is I want to go through a couple more examples of a little bit increasing complexity, and then I'll pretty much leave it at that, I think. So let's do a few examples more to get a little more comfortable with this. Okay, so I'll give us another like sort of, well, a couple more like word problem type things just to set these up. So here's a situation for us, and we're going to find a transition diagram and maybe answer a probability question about it. So here's the situation. Let's just suppose that I'm a really picky eater. So picky, in fact, that I'll only ever eat at 2 restaurants in town. And that's it. So I'm annoying to go out to eat with. I'll only eat at 2 restaurants. And we'll just say that there's a seafood restaurant or there's a steakhouse that I'll go to. Okay. So these are the only 2 types of restaurants that I will eat at all in town in this situation. Okay. And so if my most recent visit to a restaurant, or maybe if my most recent meal, let's say, was at a seafood restaurant, then there is a 2/5. There's a 2/5 chance that I eat seafood at my next meal. And a 3/5 chance I eat at the steakhouse. On the other hand, if I just ate at the steakhouse, then I have a 5/7 chance of eating at the steakhouse again. And then a 2/7 chance, of course, of eating at seafood. Next. So we're basically asking about what are the likelihoods that if I've eaten at one restaurant, that my next trip to a restaurant will be at one of these 2 restaurants. What are the odds of me transitioning from one restaurant to another, if you will. So, okay. So this is our situation. And here's maybe the probability question that we'll ask that we'll try to solve. But in the process, we'll also find the transition diagram and the transition matrix. What is the probability, or so I'll say this, if I have just had, so again, we need a starting point. If I just ate at the steakhouse, SH for steakhouse, what is the probability that I next eat again at the steakhouse? Sorry, not next. Let's say this. At the steakhouse 3 days from now. So that's small print. I ran out of room. Anyway, let's just say, what's the probability that if I eat at the steakhouse, that's my most recent meal, that my 3 meals from now, I'll be eating again at the steakhouse? What's the probability of that? So using this information, I'm going to answer the question about if I just had the steakhouse, what's the probability that 3 meals from now, I once again will eat at the steakhouse? Okay. So to answer this, let's find maybe the transition diagram. And in the meantime, we'll also go ahead and find the transition matrix, although we won't use that yet to solve the problem. But let's do those, and then we'll answer the question. Made sure to check my work extra carefully this time, so I think I won't make a mistake. But anyway, okay. So first, let's get the transition diagram written down. So I have two possibilities. There's the steakhouse and there's seafood. Okay. So let's fill in the arrows. Going from the steakhouse back to the steakhouse, that had a probability of 5/7. Going from seafood back to seafood had a probability of 2/5. Going from the steakhouse to seafood had a probability of 2/7. And going from the seafood to the steakhouse had a probability of 3/5. Okay. So this is my transition diagram for this situation, filled in like this. Just so we know, the transition matrix should look like this. So if this is, we do steakhouse, seafood, steakhouse, seafood, then I would just fill it in like this. 5/7, 2/7, 3/5, 2/5. That would be my matrix. Okay. Once again, this probability of steakhouse to steakhouse, steakhouse to seafood, seafood to steakhouse, seafood to seafood. Okay. So this is just to get comfortable writing down the matrix. We're going to actually use the transition diagram to solve the problem, though. So I'm asking about starting at the steakhouse and then eating there again 3 times from now. So what I'm really asking in terms of the transition diagram is I start where steakhouse is, and I'm going to find all possible paths through this diagram that end back at steakhouse after 3 steps. So how many of those are there? Well, let's just sort of think through the possibilities. I could start at steakhouse. I could just basically eat at steakhouse 3 times in a row, right? So I could go 1, 2, 3, and that's it. I could just keep eating at the steakhouse over and over again. So if I do that, what am I doing? I'm multiplying by 5/7 every time. So it looks like, since it's 3 steps, it should be 5/7 to the 3rd power. Multiply 5/7 with itself 3 times. So that's one possibility, is that I just eat at the steakhouse every time. Yeah. So what's another possibility? Let's make it a little more interesting. Maybe after the steakhouse, I go and I eat at seafood. And then maybe I eat at seafood again, and then I come back to the steakhouse. So that's 3 steps. That's 1, 2, 3. And so the numbers are 2/7 times 2/5 times 3/5. So I'm going to add 2/7 times 2/5 times 3/5. Okay. That's not it. There's more possibilities that I could find. Maybe I start at steakhouse and I go to seafood, and then I come back to the steakhouse, and then I do the steakhouse again. So that's 2/7, 3/5, 5/7. And then I think there's one more possibility here, which is I start at the steakhouse, I do steakhouse, and then I go to seafood, and then I come back to the steakhouse. So these are all distinct ways that I could start at steakhouse and end back at steakhouse after 3 steps. These would be the corresponding probabilities. So I think there's just those 4. And so what I would do is add up all these numbers, whatever I get. So I'm not going to simplify this step by step on the board for you, because that would be tedious, and you guys, if you really want to check, it's better for you guys to do that yourselves. So I'll just tell you what the answer should be. You should get 5,813 over 8,575. And as a decimal, that is approximately 0.6779, let's say. It trails off longer than that, but I'm going to approximate it to that. So 0.6779 approximately. So there's about a 67.79% chance that if I ate at the steakhouse, I will be eating there again 3 days from now or whatever, right? According to this example. But so to find this, I just find all paths here that start at steakhouse and end back at steakhouse after 3 steps. Multiply up every time I go across an arrow, and then add up all the numbers I get from that. Okay. And so later on in the week, I'll show you how, we might come back to this example or something, and I'll show you how to do it using the matrix. Not so bad. But so I guess I'll pause and ask, are there any questions yet? How are you guys doing? All right, sounds like no questions. That's good. Okay, cool. That's it for this example here. We could ask more questions like, what's the probability if I start at seafood, and what the probability I'll end up at steakhouse some number of days from now. I invite you guys, if you want to practice more, just make up questions and try to solve them of these kind, just as extra practice. You could basically make up anything that you want. But if you pick bigger numbers, like if I asked for you to go out 6 days instead of 3 days, you will quickly see that it does get kind of tedious chasing out all these paths. It was already slightly tedious with 3 days. It gets worse if you have the more days, the worse it gets. And so part of having us do it this way for now is, 1, to gain an understanding of what's really going on, but 2 is to hopefully convince you that we need a better method. And that's where the matrix is going to come in later. But anyway, let's not worry about that yet. Here's another example. Just double check time. Okay. I don't want to go over again today. So we're doing okay. One more of these kind of examples here. I have citizens that are employed in a small town. And they are classified into 3 types, or 3 groups. There are 3 groups of types of employees. You either work in industry, you work for the government, or you are self-employed. These are the only 3 that we're allowing in this example. And I'm going to put a table with data on it to save myself some writing. But this table is going to represent, basically, here's what I'm going to say. Let me draw out this table. So here's, I guess I'll say at end of year. So here's the typical setup. So I is for industry, G is for government, and SE is for self-employed. What I want to say is the following. I want to basically write out the table and then explain it, what it means, so that it's not so mysterious. So let me just fill in these numbers, and then I'll tell you what it's supposed to mean, how we should interpret this table. Okay, so I filled in this table. And the idea is this. So there's only these 3 types of jobs: industry, government, self-employed. And what we're really monitoring here is, from year to year, what percentage of people switch classifications. So how many people leave industry and go on to government, or leave industry and go on to be self-employed, and so forth, or any of the other combinations that you can think of. And so that's what I've written over here. So if I look in this first section, I have industry. And so what I'm looking at are all the people that are in industry and either stay in industry or switch to government